Hello and welcome to Math 252, Calculus 2 here at Cañada College. We are looking at a problem from the homework 6.2 number 4. Now this problem comes in a variety of forms. This particular one is asking us to find the interest rate. There might be times where they're asking you to find the total amount that you will get. But this one is asking for the interest rate. And so I want to call back the book and have you look at example 6.7. And for 6.7, I'm just going to grab some formulas that might be needed for that. So here are a couple of formulas that could be useful. It says using the result from part A, which again, I would ask you to look at example 6.6 or 6.7. I see that the present value P of C dollars paid annually, so C dollars is the annual payment, and your present value is the total amount that you're looking at. Over the course of n years, assuming the annual interest rate is R, is given by this formula. P is equal to C over 1 plus R plus C over 1 plus R squared plus all the way up to C divided by 1 plus R to the nth power. Now, there's this idea of having a perpetual annual payouts. And so we can take a look at that present value to equal an infinite series of C divided by 1 plus R raised to the n plus 1 power. And so this is the formula that we'll need for this particular problem, because in this particular problem we're looking for the interest rate R that would allow a perpetual annual payout of $6,000 given a present value of $100,000. So what we want to do is, they kind of do this in the example as well. What they want to do is they take this information here, this series, and find the sum. Now this is similar to the geometric series that says n goes from 0 to infinity of a times r, we can call it x to the n, is going to equal to a divided by 1 over x. And this is good for x values that are absolute value of x less than 1. Okay, so R is the rate that we're looking for. It's usually a percentage, usually a small percentage. So 1 plus that in the denominator will give this condition. Now, there's some slight bits of changes here, and the slight bits of changes is that this is 0, but the power I have for n here is different from the power of n plus 1. So what we want to do is we can take that out as maybe have it part of A. So let's rewrite this formula, P to equal to the sum from 0 to infinity of C divided by 1 plus R. So I'll take the C out, I take the 1 plus R out, and then I have a 1 over 1 plus R raised to the nth power. And so now we have our value of this thing, the A value divided by 1 over 1 minus x. So according to our formula, this should equal to A, and this is our whole A value. That's C over 1 plus R times, or in this case divided by, so I'll just divide by 1 over 1 minus x, and this whole thing is your x. So this is 1 over 1 plus R. All right, it's a complicated looking formula, but we can simplify it, and we'll find common denominators for the second fraction. So we have C over 1 plus R. We have 1 divided by 1 plus R minus 1 over 1 plus R. Let's go ahead and take the reciprocal of that. And that would be C over 1 plus R, does not change, and then we have a 1 plus R divided by This, by the way, simplifies to just r. And then we can see that 1 plus r and 1 plus r cancel, so this is just c over r. So now we actually have the relationship between the total amount of present value that we have, which is equal to the annual payments divided by the rate. So in this particular problem, it makes it kind of really simple now that we have our payments for P, and then the annual payment that we're proposing, we'll call that C. So if we just solve for R, we have 100,000 for P is equal to 6,000 for C divided by R, and then we can cross multiply or whatever else we need to do. We're going to get R is equal to 100,000 divided by 6,000. Oops, let's let's make that 6,000 divided by 100,000. And then that's just 6 over 100, or 6%. So the rate that we're looking for is 6%. Okay? Now, if your problem is changed in the sense that you're not looking for R, but instead you're looking for the total amount payout over 30 years, or over some number of years, then you would use this formula and add them all up. There's a quick way to do this in the calculator. You can certainly use a computer to figure out a sum up to some finite number, but there's also a formula for this as well. Okay, all right, that's it. Good luck.